afternoon. My name is Kwanghyo Park, and I'm professional engineer working at Quid company, Seoul. And today I would like to share some of my experiences working on the projects, dealing with some 3D scenes. So today I will go over some quick backgrounds about the environment that I'm working on and what is the process we are working to actually dealing with the customer projects, and we'll share some cases that I take care of with customers. So backgrounds. So you guys are all noticed that these 3D things are keep out during the sessions, and yes, the customers prefer using 3D objects more and more. From a single rotating car models to full 3D cluster, the 3D usage is increasing, which means we need to support these 3D scenes from very, very high-end devices to the devices that has very limited computation power. Also, the main problem is dealing with 3D is not the only the problem of the designers. These days, the developers also need to use the 3D objects and 3D scenes, which means, however, the developers who working on the embedded world is not really familiar with these 3D scenes. So they want to use it in an easy way, and they don't want to do anything, and they just want to make it happen like this. So also, in a project-wide point of view, it should be suitable for apply to various targets. So if you implement a single application and you want to deploy this application to a high-end product to a lower-end product with very small optimization. So optimization, yes, it's all about the optimization. In the embedded world, you need to optimize your application, and each includes the optimization on the 3D scenes. So 3D is very, very requires a lot of computation power and graphic power. So we need to optimize the 3D scenes as much as possible to render and working on the actual embedded hardware. So what Qt provides? So we provide something called Qt Studio back then. So you guys all know this conference, we are talking about a new 3D scenes like Qt Quick 3D. And however, the project I working on last year and this year, all we got have is this Qt 3D Studio and Qt side, and we need to working on with this Qt 3D Studio and Qt 3D Studio runtimes for the customer to provide what the customer really wants on their actual target. So this tool is quite a young tool, which provides you an easy way to integrate the 3D scene to the QML application. Also, you can control the 3D scene through the QML or within the tools. And we provide a live preview at the actual target hardware for these 3D scenes. And yes, we are preparing a much better way to implement these 3D scenes, which is Design Studio integrating with 2D scenes and 3D scenes, and which will likely replace this Qt 3D Studio. So the process, how the Qt is working with these actual customer projects. So let's see some timelines here. We are Like the Qt has its own schedule with their own release timeline. So let's say the Qt 3D Studio has its own timeline to release its major versions, minor versions, also with the Qt. However, the customer doesn't care of the Qt release timeline, and they are like to start their project at some point, and they want to fix their features at some point. And yes, Qt provides a various things with a newer Qt versions, also the Qt 3 Studio. The main, like the presentation says, the main key features of Qt 3 Studio is what may be what the customer really wants. So yes, there is compressed texture and performance optimizations. However, the customer project starts before you can provide these key features of 3D and 3D runtime. So ideally, if the customers are really familiar with this Qt and they are managing their projects, their applications, their product to be more flexible to the Qt version upgrade, then they can just download the newer Qt version and they apply the new features by themselves. Like that's very easy. And with this, they can always can use the newest feature that Qt provides. However, in reality, it never happens. The customer doesn't want to upgrade their Qt versions because it causes a lot of issues when they apply the new Qt versions. And yes, this is not something wrong with the Qt, and it's about the customer's product management and something else. But yeah, and actually, the customers does not want these huge changes while their project going on. So, however, the customers always wants a better features with their products. So, let's say the project kicks off at the Qt 5.12 timeline. And at this point, the Qt 3D Studio has 2.0 version. And they are using those two versions for their product. And about a month later, the Qt 3D Studio 2.1 released. And sometimes later, 2.2. At this point, the customer realized that, oh, we need to use some compressed texture to make our 3D scenes loading faster. And they contact us to provide that features with their product. At this point, we are talking about okay, then you guys can upgrade your Qt versions and your 3D Studio runtime version to the latest one. But the customer said, if we do that, we have a lot of issues, and we are not taking that risks to apply them. So our professional service engineers working on this. With the customer's current version and current environment, professional service engineers try to apply the latest versions to the actual customer product. So at this point, let's say the professional service engineers work on their customer's product and provide the new Qt version, 3D Studio version, which is not really, really stable for their product. And as the time goes on, the new features are kicking in and new Qt versions are kicking in, but but the customer doesn't want to upgrade the whole Qt, so keep it Qt into their starting version, like let's say 5.12, but they will upgrade some Qt 3D Studio runtime to 2.2 with some features in Qt 2.3 and more optimizations upon them. So at last, when the product features fixed, they have all the things that they needed. So the Qt and the fine running 3D Studio runtime, and some features they needed for their performance and performance optimization over the 3D Studio engine. So this is the general workflow when we are working on as the professional service engineers and professional service team. So when the customer reaching out to us to fix some issues or like we need to do this something for the performance optimization. And then the professional service engineers working on this, a specific customer specialized cases. And when they found that, okay, this is what we can handle and this is very specific, our special cases for the customers, then we working on it, investigate it, and feedback to the customer about the issue. However, the professional service engineers are not God. They are not like super key for everything. So when professional service engineers found out that, okay, this is not a really specific field and we need to more deeper insights about this issue, then we can reach out to our R&D team, where the more specialists of acute is. So, and co-work with the R&D engineers and investigate deeper about these issues. And we got the problem fixed, and then we go back to the customer. So the customer will be happy with because the problem is solved, and the code also can be improved with these kind of cycles to working on the actual issues. So I would like to share some cases that I really worked on. So first, this case is something that was really weird, but okay. So the items on one side disappears just like this. So we need to investigate what makes it happen. And apparently, we found out that when we gave a negative scale to an object, and then the object that has negative scale value disappears something like this, because the normal value is flipped. And okay, this is not what really not what the engine needs to be handled, so we guide to the designer. So I come up with this case because we also talking with the designers how they need to handle their models. In this case, okay, this feature is not suitable for Q3 Studio runtime at that point, so we guide the designer not to give the negative scale to the objects and just copy and paste, duplicate the object and do it all the right way. So the second case, this case is mainly about the performance. The 3D scene loading took too much time. So we found out that there are a lot of objects that needs to be loaded. So we investigate the actual 3D scene and what goes wrong. So we found out that all the objects which is not really visible on the actual 3D scene also is loaded. So which makes the loading time very slow. So we find out which objects is not visible at the actual scene and guide the designer to remove those objects. Also, we are talking about the compressed texture, which makes the texture loading to embedded hardware much faster. So we guide the designer to things to use the compressed texture and using less objects. So we can use the 3D scene on the actual embedded hardware. So this case goes with the really technical and developer side. So the application with 3D scene has too much time to launch. So we investigate what makes it so slow, and we found out that the 3D scene is loaded at the first screen. So which means loading 3D scene makes the loading application to launch too slow. And we did further investigation on how can we make this 3D scene loading faster. So at that point, we need these these four parts to actual loading 3D scenes. First, loading libraries for 3D. Second, the libraries for 3D runtime. Third, the actual 3D asset loading. And the time to render actual 3D scenes. So, and the parts that we can working on was mainly these two parts. Rendering itself is highly dependent on the hardware performance and really OpenGL thing. So we are not really convincing of optimizing this part at this point. So we are mainly working on how to load the 3D runtime libraries faster and how to make the 3D asset loading faster. So we are working on the optimizing libraries and assets, and we working with the designers about the objects and make the objects as light as possible first. And we reduce the loading time of the asset itself to half. And then we found out that, okay, we can reduce the loading time for the 3D runtime library itself by static linking. So in a performance point of view, you cannot have everything. So if you want to have one thing, you have to lose another thing. So at this time, we need to weigh what is better, make the binary bigger or the loading 3D library is like much have impacts. At this specific case, the environment has some problem with loading shared library at runtime. So loading bigger binary is much faster than loading the shared library at runtime. So we convinced the customer to use static linking and do not load the library at runtime. So before our optimization, the application application launch time take about 15 seconds, and it's very huge. And after our optimizations, and we shrink it to about 500 milliseconds. And another thing, CPU usage. At that point, the 3D scene consumes a lot of CPU powers. And we found out that it's because the render process is always running, even though there's nothing to render on 3D scene. And it is because the 3D scene itself has its own render, so they cannot know if the 3D scene has updates or not. So we found out a most recent patches which can detect or which can observe the 3D scene, and okay, we have the new updates, so we will need to render at some point, not rendering all the time. And this is not really, so at this point, the customer uses 5.12.2, and this patch is really under review patch. So the professional service engineers working on this new reviewing patch to apply at the actual product, and we tested it, applied it, and find it working properly. So we can provide a customer this patch at their actual environment and make the CPU usage very low. So before the CPU usage was about 30% when the 3D scene, when the application with 3D scene running, and after that, yes, it goes idle after the 3D scene is loaded and the 3D scene is not running anything. So I think it's the last case. Yes, there are pretty various scenarios that customers are using 3D scenes. And at this case, one of the items in list view wants to have 3D scene. And you may already got the idea that 3D scene loading itself requires a lot of time. And when we got this request, the customer creates this list view with repeater. And repeater creates every single items in the repeater at launching time. So they are like when their home screen is updated, the whole items needs to be updated again. And this is the problem of their application architecture at first. So we guide them to replace the repeater to the list view, which is because list view manages its item dynamically. So when the item goes out, the item will be gone, and when it comes back, only those items needed will be loaded, and this makes the whole application running time faster. However, the problem is 3D item. If 3D item goes away, then it needs to be attached again. It requires a lot of time again and again and again. So we are working on to fix this problem, and we decided to keep the 3D item when it is created again at first time. After that, when the 3D item goes out of the screen, then 3D item will be removed. But rather than we will keep this 3D item at some point at some place, and when 3D item is added to this list again, then use it again, not create it again. So this makes the whole application running more seamlessly and smoothly. So this home screen scroll and home screen editing performance is getting much better. So for wrap up, we are dealing with a very serious 3D on the embedded world right now. And the customers are requesting more various and more complex scenarios scenes with their 3D items assets. And we, as a professional services institute, are meeting our customers, and we already facing a lot of fancy 3D requests, and we need to prepare for that. And one of them will be Qt Design Studio new versions and QGIS 3D. And we are prepared to support those items. Thank you. And
yes, thank you.